This is the third lecture for Text Unit 2. This lecture is concluding the discussion of naming and finding formulas for ionic compounds. And we will then move on to discuss mixtures and the differences between chemical and physical properties of substances. We were discussing complications to naming ionic compounds, and we had just concluded dealing with polyatomic ions. We're now ready to discuss the second complication to naming ionic compounds, which is metal cations with more than one possible charge. Most of the metals that can have more than one possible charge in a compound are transition metals. In this course, we will focus on the metals in particular in Table 2.4. Table 2.4 of the text shows possible charges for various metals. For example, iron may have a charge of +2 or +3 in ionic compounds, and the same is true of chromium and cobalt and manganese. Lead and tin are actually not transition metals, but they have positive charges of 2 or possibly 4 in ionic compounds. Gold and copper have different possible charges too. Gold has a charge of +1 or possibly +3. Copper may have a charge of +1 or +2. We will use the stock system of nomenclature for dealing with ionic compounds with cations with more than one possible charge. This system uses Roman numerals to indicate the charge of the cation. Again, the Roman numeral indicates the charge of the cation. Let's look at some examples. For example, if a compound has the formula FeO, the oxide has a -2 charge. That means this iron must have a +2 charge, and we would name this compound iron 2 oxide. Notice the 2 does not indicate that there are 2 irons. There aren't. It does not indicate that there are 2 oxygens. There aren't. The 2 indicates the charge of the iron. Likewise, if a compound has the formula Fe2O3, 3 oxides would provide a charge of -6. Therefore, there must be 6 positive charges, which means each of these 2 irons must have a +3 charge. The name of this is iron 3 oxide. 3 indicates the charge of the iron, not that there are 3 oxygens. All right. Go ahead and attempt the following. Stop the presentation and attempt the following examples before moving on to see the solutions. You should be able at this point to write down formulas for copper 1 oxide, cobalt 3 sulfate, and lead 4 oxide. Copper 1 oxide would need 2 copper atoms with +1 charge to balance the negative charge of 1 oxide, and hence has the formula Cu2O. Formula of copper 1 oxide again is Cu2O. Cobalt 3 sulfate, each cobalt has a +3 charge, sulfate has a -2 charge. Positive and negative charges may be balanced with 2 cobalts to every 3 sulfates. And in the case of lead 4 oxide, a cation with a +4 charge would require 2 oxides to balance with negative charges. So the formula for lead 4 oxide is PbO2. Let's move on to the last type of substance in Unit 2, which is mixtures. We've covered elements, we've covered compounds, we're now moving on to mixtures. A mixture is a combination of elements and compounds simply mixed together. the name might imply that there are no definite proportions in a mixture. For example, salt water mixes two compounds, sodium chloride and dihydrogen oxide. The mix can have varying degrees of saltiness. In other words, there is no certain proportion of sodium chloride to water in a saltwater mixture. Mixtures can be separated into two categories. A homogeneous mixture has one phase, whereas a heterogeneous mixture has multiple phases. Here, in this word and in this course, we use the word phase to mean a region of uniform composition and physical state within a mixture. So, examples of homogeneous mixtures with one phase are Kool-Aid, lemonade, the aforementioned salt water. All three of these mixtures have one liquid phase. And brass is an example of a homogeneous mixture. It's a mixture of copper and zinc. It's a solid homogeneous mixture. Examples of heterogeneous mixtures where different regions have different compositions include sausage burritos, etc. We can conclude with a definition and discussion of chemical and physical properties of substances. A chemical change is any change that results in making new substances, and in this case we mean elements or compounds. For example, burning wood produces carbon dioxide and water. Combustion of hydrocarbons like wood produces carbon dioxide and water. This is an example of a chemical change. There are new substances, carbon dioxide and water. These were not there before. A physical change is any change that does not make new substances. It is good to point out in particular that melting and boiling are not examples of physical changes, not chemical changes. In other words, if you melt ice to water, turn it from solid to liquid, all you've done is change the physical state of the water. You have not made a new substance. If you have these definitions of chemical and physical changes, it's very easy to determine chemical properties and physical properties. Chemical properties pertain to chemical changes. For example, wood burns. We've just seen that that's a chemical change. Physical properties are any that do not pertain to chemical changes. So, for example, the melting point of ice to make liquid water is 0 Celsius. This is a physical, not a chemical property. All right, this concludes the third lecture on Unit 2.